This production is brought to you by the University of Edinburgh.
Welcome along. This session is all about importing and plotting experimental data in MATLAB. So you may have collected data in a lab and you want to import it into MATLAB to plot. Now there are various ways of getting the data into MATLAB. If you don't have a large volume of data, it might be simplest to enter it in the command window by creating vectors and arrays like we've done in previous sessions. But for larger volumes of data, you might, for example, want to import it from an Excel file. In my current directory, I have an Excel file called Concrete Beam, which contains some data from an experiment that I want to import. Now before we go ahead and import it, let's have a look at the file in Excel. We can do that directly from MATLAB by right-clicking on the file and choosing Open Outside MATLAB. This was an experiment in loading a reinforced concrete beam. We incremented the load in steps of 2.5 kilonewtons and we recorded the central deflection with 2 transducers. So let's quit Excel and go and import this data into MATLAB. We do that by using the import wizard, which can be found under File and Import Data. So I choose the Concrete Beam Excel file as the one that I want to import. And MATLAB launches the import wizard. Now you can see that MATLAB has recognized 3 separate different data portions from my Excel file. And if I click on each of them, I can see what's in them. First one contains some text data. The second one contains the 3 columns of raw data that I want to import. And the third one also contains some text data. So in this case, all I'm interested in doing is importing the raw data, so I'll uncheck the other 2. And when I click Finish, you'll see that there's a new variable in my workspace called Data. Now what I'm going to do is split that matrix into 3 separate column vectors of data. So let's go ahead and do that. We'll extract the load data first, which is all the data in the first column. Then we'll go ahead and extract the 2 deflection data sets. First of those is all the rows in the second column. And the second of those is all the rows in the third column. So now I have 3 variables, load, deflection 1 and deflection 2, containing the data that I want to plot. Before I go ahead and plot it, what I want to do is save these variables in a MATLAB file, so if I need to use them in a later MATLAB session, I don't have to import them again from Excel. So I'll go into the workspace and I'll right click on data and just delete that because I don't need it. Then I'll select deflection 1, hold down Shift and select the remaining 2 variables. I'll then right click and choose Save As. I can then save these variables in a MATLAB file in my directory, and we'll just call them Concrete Beam. And you'll see now in the current directory there's a MATLAB file called Concrete Beam which contains these variables. So let's go ahead and plot them. We simply use the plot command for that, and in the first trace we want to plot load against deflection 1, and we also want to plot load against deflection 2 as a second trace in that same plot figure. So I'm going to launch the interactive plot tools to annotate this plot now. And the first thing I'm going to do is label up the 2 traces. So I can select the first trace and label that deflection 1. And do a similar thing for the second trace. What I'm also going to do whilst I'm here is remove the line from these traces and plot the discrete markers. select a slightly more appropriate colour and just make them a little bit more visible. And just do the same with my first trace. Again, typically with experimental data, we just want to see the discrete data points. We might look at doing some curve fitting, which we'll describe in a later session. So now we've labelled up our two data sets. Let's click on the axis and apply some axis labels. So our x-axis is load, and not forgetting the units, kilonewtons, and our y-axis is deflection. And the units are millimeters for that. We'll turn the grid on, and we'll also give the plot a title. So the last thing we want to do is add a legend to the figure, and we do that by selecting the Insert and Legend option. But you'll notice that MATLAB has placed the legend over one of our data points, so we can correct that by selecting the legend and choosing a better location. So now that we've done annotating, we'll turn off the plot tools and we can save our plot. Remembering that it's always good practice to save a .fig version of the file so that we can edit it in future. So I'll choose a name and I'll change the file type to a MATLAB.figure file and save that. And in addition, I'll also save a JPEG copy so that I can insert it into a report if I want. And that's a simple example of how to import experimental data into MATLAB and plot it.
This production is copyright the University of Edinburgh.